For this kind of question, of course, you are going to use calculator to substitute some angles. For example, like when theta equal to 17, and then you have a target value, and then you are going to test which of the option will give you exactly the same result. So by using this logic, you can spot out which one is the answer, because no matter what is theta, the answer should be also consistent. This is a substitution method that you can use, or if you use the traditional method, there are two items we need to change. First one is cosine 90 degree plus theta. The second one is sine bracket 360 degree minus theta. Just try to simplify it first, one by one. Cosine 90 degree plus theta. If we draw on the graph, we are talking about this is 90 degree, 0 degree, 180 degree, 270 degree. 90 degree plus theta is here. And that means it is related to remaining angle. We are trying to refer to this graph. So cosine 90 degree, first, it is in the sine region. So when I change it, negative will be generated. And then because it's related to remaining angle, cosine will become sine theta. Whenever it is related to y-axis, then the ratio will change from sine to cosine. Tangent will change to tangent, from tangent to 1 over tangent. So for more details, maybe you can find your textbook anyway. And then, so after that, sine 360 degree minus theta. This one is easier because it's related to x-axis. It's not related to remaining angle. So this one, if you change it, you just need to consider this one is cosine region. So for sine region, when we change it, we need to have a negative sign here. And then sine is still sine ratio, sine theta. We are comparing with the same ratio, sine ratio. So after that, we can conclude our answer is cosine 90 degree plus theta plus 1. That means negative sine theta plus 1. And then another part, sine 360 degree minus theta minus 1. That means negative sine theta minus 1. So if we both items, we are multiply negative 1, sine theta negative 1. We can do so because negative 1 times negative 1 is positive 1. No change at all. So expand it, we get sine squared theta minus 1. And be reminded that 1 is equal to sine squared theta plus cosine squared theta. So this is sine squared theta minus sine squared theta, and then minus cosine squared theta. This one cancel out, and then this is our answer after simplification. The answer is A. Okay, maybe some student want to know how come cosine 90 degree plus theta will become negative sine theta. Maybe this is some demonstration. But first you have to accept if the angle is related to x-axis, how we change it. You have to accept this one first. And then we may to calculate this one, to put it like inside the first region, we try to consider cosine 180 degree minus something. And we know that is equal to negative cosine something, right? That means, in other words, if I want to have positive cosine A, that means negative this item. So now cosine A is referred to this item, and then we try to transform it into this format. If I do so, it will become negative cosine 180 degree minus 90 degree plus bracket theta, and then negative cosine 90 degree minus theta. So by using remaining angle, if you still remember, if this is theta, This is 90 degree minus theta. So because the relation adjacent of theta will become opposite of 90 degree minus theta, that's why for remaining angle, cosine function will change to sine function of that remaining angle. So that's why we say that whenever it is related to 90 degree, it is talking about remaining angle, and then you have to change the ratio.